Okay, good morning, children. So today, the thing that we'll be doing, it comes under the topic chemical energetics. Chemical energetics, that is, energy changes during a chemical reaction. Before that, let me tell you, we had talked about enthalpy change. We had talked about internal energy change. Enthalpy change is QP, heat change at constant pressure, and internal energy change is heat change at constant volume. And these things are measured. These are measured, in a calorimeter. This in particular is measured in a calorimeter, which is called bomb calorimeter. And this also is measured in a calorimeter. So we can find out, we can experimentally determine delta H and delta U, by calorimeter. Okay, now today what we are doing is first of all enthalpy of reaction. Enthalpy of reaction, which is written as delta HR, enthalpy of reaction. So, what is enthalpy of reaction is, suppose we have a reaction, say A plus B arrow C plus D. Suppose this is a chemical reaction, and A, small b, small c, small d, are the coefficients. So during this process, what is the enthalpy change? What is the enthalpy change during this process? What is the enthalpy change during this reaction? That is called delta HR. And this delta HR, can be found in this way: C into molar enthalpy of substance C plus D into molar enthalpy of substance D minus A into molar enthalpy of substance A minus B into molar enthalpy of substance B. So this is the relation you have to remember, by which we can find out the enthalpy of reaction. That is products minus reactants. So this we can also write in this way: summation of molar enthalpy of products minus summation of molar enthalpy of reactants. So we have to remember that this molar enthalpy, of course, has to be multiplied by their corresponding coefficients. Okay, now this enthalpy of reaction depends on the condition of reaction. Since enthalpy of reaction depends on the condition of reaction, we have to choose a standard condition. We need to choose a standard condition because a particular reaction, if carried out in different condition of temperature and pressure, will give us different value of delta E chart. That is the reason why we choose a particular condition, to compare enthalpy of reaction for different reaction. We choose a particular condition, and that is called, standard condition. Standard condition. The standard condition we generally choose in thermodynamics. It is at temperature of 25 degrees Celsius or 298 Kelvin, and at pressure of 1 bar. So under this condition, the enthalpy of reaction is called standard enthalpy of reaction. This not here, it represents standard enthalpy of reaction. So this is standard enthalpy of reaction. So that is enthalpy of reaction at standard state of 298 Kelvin temperature and 1 bar pressure is called standard enthalpy of reaction. Now, children, why we consider this enthalpy of reaction? Why we are studying this enthalpy of reaction? Because from this value of enthalpy of reaction, we can design condition. We can design condition to carry out a particular process, to carry out a particular reaction. This you will be understanding better later on. For example, in industry where some chemical reactions we need to carry out, we need to plan. We need to plan the reaction. We need to design particular condition for the reaction so that reaction occurs better and we get good in the product. And that designing and setting condition is only possible if we know enthalpy of reaction. If we know standard enthalpy of reaction. Okay, now there are different types of enthalpy of there are different enthalpy, different enthalpy. For example, say suppose this process H2O liquid to H2O gas. So this is phase condition. This phase condition, and for this we will have enthalpy of, this is what process? Vaporization. So this is, we can write vaporization. Enthalpy of vaporization, and if it is taking place in standard state, so this is delta H vaporization naught. Similarly, suppose if you have H2O liquid to H2O solid. Liquid to solid, it's called fusion. Sorry, liquid to solid is called solidification. So we can call it as delta H of your solidification. Then say H2O solid to H2O liquid. This is called solid to liquid. This process is called melting or fusion. So here we write delta H naught fusion. So all these are physical processes. Different physical processes have different enthalpies. Okay, say one more I am telling you is that the carbon dioxide solid is changing to carbon dioxide gas. So solid to gas directly, this is called the enthalpy of sublimation. So these are the different types of enthalpy involved in physical process. Okay, now a very important term, I am telling is that is standard enthalpy of formation. Standard enthalpy of formation. And its symbol it is delta H naught, and since it is formation we write here F. So what is standard enthalpy of formation? Let us consider formation of a substance. Suppose benzene. Benzene is C6H6 benzene, and normal physical condition, normal physical state of benzene at temperature of 298 Kelvin, benzene is liquid. So we write here L. So benzene, which is liquid, we have to consider the formation of benzene, from its constituent element. The constituent element of benzene, it is C graphite. Now you see there is another form of carbon, diamond, but the thing is that we have to consider we have to take the most stable state of aggregation, and which is graphite. So graphite, and what is the other element present? Hydrogen. So hydrogen, which is gaseous, and so this physical state has to be mentioned, and we have to balance this. Since it is 6, so we write here 6. Since it is 6 hydrogen, we write here 3. So you see 1 mole of benzene is being formed from its constituent elements, and the corresponding enthalpy change that will happen, that is called the enthalpy of formation. The corresponding enthalpy change, and if it is happening at standard condition, then it is called standard enthalpy of formation of benzene. Let us consider another process, say ethyl alcohol. Let us consider the standard enthalpy of formation of ethyl alcohol. Ethyl alcohol, it is liquid again in normal condition, so we have to consider its formation. Very important, 1 mole has to be formed from its constant element. So here again C graphite plus hydrogen gaseous plus O2 gaseous. So all the constant element written. Now we have to balance it, keeping here this side 1 mole. So it will be, since there is only 1 atom of oxygen, so half O2. There is 6 atom of hydrogen, so 3H2, and 2 graphite. So you see 1 mole of ethyl alcohol is being formed from its constant element. So this is enthalpy of formation, standard enthalpy of formation of ethyl alcohol. These values will be there, like their unit will be generally in kilojoules per mole. Its unit will be in kilojoules per mole. Okay, now one question here, I would like to ask you here one question is that suppose let us consider this process. I am writing the process here. Calcium carbonate solid, CaO solid plus CO2 gas, and enthalpy change value, it is given, it is experimental determinant minus 178.8 kilojoules per mole. So the question is, for this process, is this value enthalpy of formation of calcium carbonate? Is this value enthalpy of formation of calcium carbonate? The answer is no. The answer is no. Why it is not enthalpy of formation of calcium carbonate? Because you see, though 1 mole of calcium carbonate is formed, as here 1 mole is formed, but as it has been said in the definition, it has to be formed from its constituent element. Now calcium oxide is not an element, it's a compound. Carbon dioxide is not an element, it's a compound. So this value of standard enthalpy change, is not enthalpy of formation. It's not enthalpy of formation. Okay. Now you see in NCERT book on page 167, you have standard molar enthalpies of formation at 298 of few selected substances. Okay, these values are given. You have to refer to this table. You don't have to learn these values. These values will be supplied to you in the exam. And what we need to do now is, what is the importance of these values? What are the importance of standard molar enthalpies of formation? That we are going to discuss now. When you see these values, you will see that suppose free elements, you will see standard molar enthalpies of free elements, you will see it to be 0. That you have to remember. Okay, standard molar enthalpies of free elements is 0. Okay, now coming to the importance of these values, importance is we can calculate standard enthalpy of reaction for a particular reaction, from standard enthalpy of formation. So that I am going to show here. That means that this is application of your standard enthalpy of formation.